All right, Algebra 2, Chapter 2, practice test. So describe the transformation of f of x is equal to x squared, represented by g of x is equal to x minus 3 squared plus 4. Then select the correct graph of each function. So remember, it's going to be the opposite of this one. It's going to be the same as this one for the vertex. So your vertex on this one here would be at 3 and 4. All right, we're looking at this. That's our original one at the origin. So remember, if we're looking at this, I'm going to say it's 3 right, because the negative will move it right, and it goes 4 up. All right, so as I told you in class, you should be able to, the x squared is that going to be at the origin, so you're going to kind of look and see how can you move it. So if I move that 3 right, and if I move it 4 up, that will give me my vertex, which we just said was 3 and 4. And it's still the vertex right there, so it has to be this one here. Number 2, same kind of thing. Remember I told you on this one here, there's a negative that's on the outside, so it's going to be a reflection over the x-axis. So if it was opening up, it's going to open down. So knowing that, you can get rid of this one here right away. And let's see, our vertex on this one here would be at -3 and +2. So on that one there, excuse me, again, you're going to go 3 left and 2 up. So look at the ones that will be going down, and that is going 3 left and 2 up. So it looks like it's this one here, 3 left and 2 up. There's our vertex, and so it has to be that one right there. Okay, let the graph of G be a vertical shrink by a factor of 1/5, followed by, so there's a keyword, followed by translation. So that tells us we're going to be doing 2 things of 8 units down of the graph of f of x is equal to x squared. So it's still our family function on this one here. So again, I'm going to first do a vertical shrink. So I'm going to have, let's see, h of x is equal to 1/5 our f of x. So again, it's on the outside. So that would equal 1/5 x squared. Then our g of x, which is the one that we're going to finish up with, we're going to take our h of x. And again, since it's 8 units down, it's going to be on the outside. So our final answer will be 1/5 x squared minus 8. And again, like I told you before, make sure when you're looking at this, are you talking about the g of x? Do they already have it? Don't put it down again. Number 4 says, let there be a horizontal shrink. And you guys were telling me good stuff here. Whenever you see horizontal shrink, you're going to tell me, you're going to take that factor, you're going to flip it over, and you're going to attach it to the x. All right, so on this one here, we would say our h of x then. Oh, and remember on this time here, they did say and, so we're doing 2 things at once. So we have a reflection in the x-axis, so that means it's going to be outside. So we're going to have our h of x is going to be our negative. There's our, excuse me, that's our reflection in the x-axis. And then I told you we're going to take our x and we're going to attach the 6 to it. All right, so when I do that, there's my negative. We're going to attach the 6 to the x, and it's going to be squared. Then we're going to follow that by, again, there's that word followed by, 2 units down. So we're going to say g of x is going to be h of x, and minus 2, so it's on the outside. So we would say that is negative 6x squared minus 2. That's your g of x. Okay. Remember, I talked about if you wanted to say 36x squared, you could probably get away with saying it like that. But again, they gave me that answer. So I think that's good enough. Number 5, it says let the graph of g be a translation 2 units down, followed by, so there's 1, followed by a vertical stretch, so that's going to be on the outside, and a reflection in the x-axis, again, on the outside. This time, though, we aren't talking about x squared. This is our function here, so we're going to have to use that. So knowing that, I'm going to go and do h of x is equal to our f of x. Again, it's on the outside y, I keep telling you. So we're going to say minus 2. So then we'll have x squared plus 7x minus 2. Now your g of x, we are doing 2 things. So we're going to do a vertical stretch by a factor of 9. So I'm going to have 9 times h of x. But then they're also telling me I'm going to have a reflection in the x-axis. Again, that's on the outside. So now we're going to take our negative 9, and then we have x squared plus 7x minus 2. That is our h of x. So now I'm going to take that 9 and distribute it through the parentheses. So that'll be a negative there also, excuse me. And then plus 18. And that's your final answer on that one. All right, on number 6 here, I told you, again, I did one of them for you, and then I did the other one. So on this here, let's go ahead and look at where our vertex is going to be. So it's going to be the opposite of this one. So it's going to be negative 6, and it's going to be the same as that. So that's going to be our vertex is at negative 6 and negative 5. So I go to negative 6 and I go down negative 5, and that's my vertex. All right, now that's also where our line of symmetry is going to be. So I told you you really can't do this on here, but I can do it for you right here. And we're just saying that our line of symmetry, or axis of symmetry, is x is equal to negative 6. So then they told us that they wanted us to get values that correspond to negative 2 and negative 4, and then to plot these in their reflections. So I did f of negative 2 for most of the classes. And that is, again, wherever I see x, I'm replacing it with negative 2. So I'm going to have negative 2 plus 6 squared minus 5, which is 1/4. Negative 2 plus 6 is positive 4 squared minus 5. So 4 squared is 16. 1/4 of 16 is 4. So I'll have 4 minus 5. And that will give me negative 1. So they're saying when x is equal to negative 2, y is negative 1, and that is your point. Remember, from there I told you that you're going to count to that axis of symmetry. So there's 1, 2, 3, 4. And you're going to go the other way. 1, 2, 3, 4. And that's where you're going to make your other point. And again, for simplicity's sake and to not spend all night here, I told you on f of 4, and when you plug that in, you'll get negative 4. So when I'm at x is equal to negative 4, y is equal to negative 4, and again, by symmetry, it takes me 2 to get to the axis of symmetry. I'm going to go 2 in the other direction, and I'm going to make my points. So those are the 5 points that they want you to put on there. Okay. Number 7, find the minimum or maximum value of f of x is equal to 2x squared minus 16x plus 30. So on this one here, remember, that is your a value. Your a is greater than 0. So you know that it has to be a minimum. Remember, again, I showed you real quick. It's kind of doing this. Your minimum is here, so it's opening upwards. So right now we can at least say that's a minimum. Okay. Remember, to find it, it has to be the y value. So you have to find the x value first. So x is equal to negative b over 2a. So our b is negative 16. And our 2 times 2, our a is 2. And when I work that out, I'll get 4. Now that's not my answer, so don't put 4 there. I'm sure that's probably a choice that you can put there on that drop-down menu. But I want f of 4 is equal to 2 times, again, I'm plugging in, wherever I see x, I'm replacing it with 4. So 4 squared is 16 times 2 is 32, minus 16 times 4 is 64, and then plus 30, and that will give us negative 2. So the value here is negative 2. That would be the one that you would have to put there. Okay. I kind of showed you on this one here why it was. All right. So remember, it's just going to be the opposite of that. So P would equal negative 2 and Q would equal negative 8. All right. Just always think of it's the opposite. So those are our x-intercepts. So negative 2 and negative 8. Remember, to find the vertex, to get the x value of it, or our h, we would take p plus q divided by 2. So that'll be negative 2 plus 8, negative 8, divided by 2, which will give us negative 5. So I told you again, that's my x value of my vertex, and that is also my axis of symmetry. And then to find my y value, again, I'm going to plug in negative 5 wherever I see x. So when I work that out, I'll get negative 25 hundredths times a negative 3 times a positive 3. I have two negatives there. Negative times a negative is a positive. So now I would just go ahead and work on everything, and I'll get 2.25, or 2 and 25 hundredths, and that is your y value. All right, on this one here, I told you it was the focus of a parabola. All right, if it's the focus of a parabola, we know that we have either the focus or the directrix. We might have both. On this one here, we have the directrix. So remember, our vertex is h and k. In this case, it's negative 3 and 0. And our formula would be y is equal to 1 over 4p times x minus h squared plus k. All right? So remember, your directrix, which is right here, if you look, you can tell that it is the line y is equal to negative 2. But again, we have to say that y is equal to k minus p. In this case, it's 0 minus p. And I just told you we could see that it was equal to negative 2. So again, if I have negative p equals negative 2, I'll have that p is equal to 2. So then we're going to just plug that into our equation. Y is equal to 1 over 4 times 2 Then we have x. Again, the easiest way to think about it, you have a -3 there. So just take the opposite of it. And then we have plus k, which is 0. So to simplify that, I'm going to say 1 over 8. And I have x plus 3 squared. And then I'm done. All right? You could put plus 0, but again, remember what I told you is that on this one here, it doesn't have a y equals. All the other ones had g of x equals or y equals. So on this one here, you will have to put y equals because they do call it an equation. And if you don't put that, it will mark it wrong. I'll be nice enough to give you credit, but eventually somewhere down the road, somebody else might not be. All right, number 10 was the one where I had to write a bunch and then get rid of it. So I'll probably have to do the same thing here, so pay attention. Well, you can always pause it on here. So it's saying write an equation of a parabola that passes through the point 3 and -30. So again, that's my x and that's my y, and has x-intercepts of -2 and 18. Then find the average rate of change from x is equal to -2 to x is equal to 8. So since they didn't give you the equation, you're going to tell me that y is equal to a times, and this time I told you, when they don't give you the equation, just take those and take the opposite sign. So you would have x plus 2, and then you would have x minus 18. So now we're going to plug in that point, 3 and -30, so -30 is equal to a times 3 plus 2, and 3 minus 18, and that'll give us -30 is equal to a times 5 times -15. 5 times -15 is -75, so I'll say -75a is equal to -30. A is equal to -30 over -75, which will come out to 0.4. All right, so your equation on this one here is 0.4 x plus 2 x minus 18. All right, so that is our equation. Notice I didn't put the y equals there because they already told us that. All right, maybe I'm writing small enough I can actually put this all in here. So remember, your average rate of change and I'll just say ROC for rate of change, is again, it's f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. Let me make that 2 a little better there. All right, so we're going to have to plug in what our f of 8 is. So we're going to plug it in over here. I'll plug it in over here. So f of 8 is equal to, again, I'm going to use my equation that I just found the 0.4 for, and then I'm going to plug in 8 for x. So I have 8 plus 2, and then I have 8 minus 18, right? So then I'll have 0.4 times 10 times -10, which is -40. All right, f of x, or f of -2 in this case, I'm going to say it's 0.4 times -2 plus 2. Remember, I'm plugging in for x. I'm replacing it with -2. And I'll have -2 minus 18. So on this one here, this right here becomes 0. So now I have 4/10 times 0 times -20. Well, it doesn't matter what everything else is. When I multiply by 0, it ends up being 0. All right? So on the top here now, I have, let's see, I have negative 40 minus 0 over on the bottom. I have 8 minus a negative or plus 2, which will give me negative 40 over 10, which is negative 4. And so that's our average rate of change for that one. It's negative 4. All right. Number 11, I told you again, don't worry about using the distance formula. All right. On this, it says write an equation of the parabola with focus of 4. So again, that's going to be your focus of a parabola. This one here is at the origin. So you are going to say that is 0 and p. So your p is equal to 4. So even on here, when I put y is equal to negative p, or excuse me, that's what I meant to put, not negative 4, because you already know that. If you look at it here, this right here is telling us our p is equal to 4, and even right here, since they're both negative, we know that we're also saying that p is equal to 4. So on our equation, we're going to write y is equal to 1 over 4p x squared, which is equal to 1 over 4 times 4 x squared. So y is equal to, and on this one they have the y there again, so be careful, is 1 over 16 x squared. And that's your answer for that one. Okay. So now on this one here, again, I told you it was just a wordy problem that was pretty simple. So a football player kicks a football downfield. The height of the football increases until it reaches a maximum height of 15 yards, 30 yards away from the player. A second kick is modeled by f of x is equal to negative 0.032, or that would be 32 thousandths. X times x minus 50, where f is the height in yards and x is the horizontal distance in yards. Compare the distances that the footballs travel before hitting the ground. So you're looking at the actual horizontal distance. On the first one, what they told you is that a player has kicked the ball, and when it reaches its maximum height, it's at 15. All right. And he said it was 30 yards away from the player. So that would tell us that this part is 30. Remember, as it by symmetry, it's going to go down the same way. And so we'll have 30 also here. So this point here is going to be 60 and 0 because it's on the x-axis. And again, at the origin, it was 0 and 0. For the second one there, remember, you can write that as 0.032 x minus 0 times x minus 50. And on that one there, you know your intercepts are going to be at 0 and 50. So one's at 0 and 0. The other one's at 50 and 0. And again, we know that it's going to have a parabola shape also. And on that one there, the key is to look at the end result. So the first one was 60, the second one was 50. So which one travels the farthest? That would be in the x direction. So if we notice that, the first one will go farther. So you'll have on the drop menu first, and then how far does it go? Farther? Oh, it goes 10 yards farther. Okay? And I believe that is where I finished with everybody. So 13 is new. So on this one here, you have a vertex. And 1 point. So on this one here, you would use the vertex form. So remember, the vertex form is y is equal to a times x minus h squared plus k. So again, you're going to tell me your vertex is right there. So that will be your h and your k. So you're going to tell me it's the opposite for the h there. So it's going to be x plus 5, quantity squared. And then the other one is going to stay the same. So it's going to be at 1.5. Now we're going to have to solve for our a. So in this case here, they gave us the point 0 and 4. So there's my x, there's my y. So you're going to tell me that 4 is equal to a times 0 plus 5 squared plus 1.5. So now I'm going to subtract 1.5 from 4. That will give me 2.5 is equal to 0 plus 5 is 5. 5 squared is 25. So on this side, I'll have 25 times a. Now to get a by itself, I'm going to take 2.5 and divide it by 25. And that will give me 0.1 or 1/10. So our equation on this one here would be 1/10 times x plus 5, quantity squared, plus 1.5. But I notice with some of you, you keep forgetting to put the x squared. Don't forget to do that for me, okay? Let's see, the next one here is a shopping mall. Manager creates a parabola to predict the number of shoppers in a mall where x is the number of hours since 8 a.m. and y is the number of shoppers in the mall. Write a function f that models the number of shoppers in the mall over time. Then find the average rate of change in the number of shoppers over the interval in which the number of shoppers is increasing. Round your answer to the nearest whole number. So on this one here, if you look at it, you have x-intercepts. So since you have x-intercepts, use the intercept form. So remember on that, it's going to be y is equal to a. Now you don't have to put x minus 0, but for some of you, you might put that just for a second. And then the other one is going to be x minus 12. Again, we have a positive one there. Take the opposite sign. So now we have to solve for a. So our point, the only point they gave us was, there's our x and there's our y. So we're going to say that 344 is equal to a times 4 minus 0 times 4 minus 12. So if we take that, we'll have a times 4 times negative 8. So we'll have negative 32 times a is equal to 344. So now I'll divide both sides by 32. So I'll get a is equal to 344 divided by negative 32, excuse me. And that will give you negative 10.75. All right. So that's going to be important for us because we have to write our equation. So our equation here would be negative 10.75. Again, I believe if you just leave it as x, that'll be better than writing x minus 0. But if you put x minus 0, I'm pretty sure it will not mark you wrong. But the other one has to be x minus 12. All right? So now, remember, to find the average rate of change, first thing we need is the vertex. So we still need the vertex. So remember, on this one here, we're going to say it is x is equal to, again, 0 plus 12. So that's our P and our Q divided by 2, which is going to equal 6. So we know our axis of symmetry is going to be there. Again, you can't put this here, but I'll put it there for you. So we can say that x is equal to 6. And then we're going to plug in f of 6. So we're going to say that f of 6 is equal to negative 10.75. All right, I have 6, and then 6 minus 12 is going to be negative 6. So our vertex then is going to be at 387. All right, so our vertex here, and I'll put it in red for you, is at 6 and 387. All right, so then what they want us to do is they want us to find the average rate of change over which the interval of the number of shoppers is increasing. So again, since it's increasing, you know it's going to increase from 0 to our vertex. So luckily, they're only making us do 1. So again, the average rate of change and I'm going to say f of 6 minus f of 0, because again, I chose this to be my x2 and y2, and this is my x1, y1. If you went the other way, you would still get the same thing, people. All right, so then we would say, and that would be over 6 minus 0. Well, I just told you f of 6, we just solved that, is 387. And then that's going to be minus 0 over 6 minus 0, which is 6. So then we would have 64.5 if you put it in your calculator. So 387 divided by 6 is 64.5, but can't have half a person. So you're going to tell me that it is equal to 65. So at the maximum there, the average rate of change was about 65 shoppers per hour. All right, and the last one shows the table, shows the prices X in dollars of a product at several different stores and the profits Y in dollars generated by selling the product. Use a graphing calculator to write a function that models the data and round each value in your function to the nearest hundredth. So on this one here, I think I can do this. Let's see. So I did make one here for you. All right, remember you would add the table up here. All right, so we've already done that. I already did that for you. And then I told you, remember, to go to this plus here so you can kind of see what is happening. All right, so it gives us a nice little view there. All right, and this, remember, on this one here, they said to do it to 2 decimal places. So again, I'm going to go here and I'll go ahead and do this for you. You're going to say y, and then you're going to go to the ABC, and you're going to do A/B. You're going to go back, and you're going to put in the number 1. All right, then you're going to tab over, and then you're going to use the tilde, and then you're going to tell me that is ax1 squared plus bx1 plus c. So you're going to tell me that's a x sub 1, and then we should be able to square it. And then you're going to tell me that's plus b x sub 1. And look how nice it's looking for us. And then we're going to say plus c. All right, so now let me get rid of all of that. And remember, look at what you have there. And remember, r squared, the closer it is to 1, the better it is. So it's actually a pretty good fit. So on this one here, you're going to look at that. And you might want to write these down somewhere because it does say to the nearest hundredth. So the nearest hundredth is 2 after the decimal. So if we look at that, and I'll put it on our thing here, you're going to tell me that that was 2 decimal places. So you would tell me then, again, using the regression, we got A is equal to negative 0.98. Then we got B was equal to 75.83. And C was equal to negative 780.68. So all of them, they said to round to the nearest one. So there's our equation. So remember, again, it was y is equal to negative 0.98 x squared plus 75.83 x minus 780.68. So you're going to have a similar one like that on your test, ladies and gentlemen. You should be able to do this. Again, I'm giving you plenty of time to do it. Good luck, and I'll see everybody tomorrow.